Hello, AP Physics students, and welcome to this first screencast or video lecture, whatever you want to call it, by yours truly, Mr. Welch. And this screencast is going to be a trigonometry review for you. Trigonometry, I feel, is very important within physics because oftentimes we don't have, whether it's forces or velocities, we don't have them acting all the time in perfectly horizontal or vertical orientation. So sometimes we need to break things down into components, and we need to use trig to find those components. So making sure that we're solid with our trig is very important. So to begin, I just have a very basic right triangle here. It's a 45, 90 degree triangle, and I've just designated this angle as theta. Okay, theta is the term that we're often going to use for an angle. So when we designate an angle as theta, we just need to remember that we have three sides to our triangle, and with whatever angle we designate theta, we have a side that's opposite, and we have a side that is adjacent, and I hope you remember that the longest side of our right triangle is called the hypotenuse. And if you think back to your trig days, which for some of you might have been 2 years ago, for others it might have been last year, you'll remember we have three trigonometric functions. We have sine of a triangle, we have cosine, and we have tangent of that angle theta. And the important thing to remember within this, with these trig functions, is that they're just numbers. They don't have a unit. They're basically just a ratio of the lengths of two sides of a right triangle. And an easy way to remember these trig functions is so, ka, toa. Okay, so if we were trying to find the sine of a particular angle theta, we would be going so. So we would have sine theta is equal to opposite over hypotenuse. Okay, and if we were trying to find the cosine of theta, or that ratio, we'd be saying co. So ka, okay, so we would be having adjacent over hypotenuse. And then finally, toa, we would be taking, let's see, what color do I want to use here? We would just be going opposite over adjacent. Okay, so those are our three big trigonometric functions. Now, we can take this a step further, and I could ask you in a problem, what is this angle theta? Well, from these trig functions, we can't really get it because these are just, again, just giving us a ratio of these two sides that we're looking at in these functions. But we have these things called inverse functions, inverse trigonometric functions, where we can find theta from those three trig functions. So all we would want to do then is just take the inverse of those trig functions. So let's say that we knew the opposite side and the hypotenuse of an angle. So we would be taking sine, or inverse sine rather, of our opposite side and our hypotenuse, and that would give us theta. Similar thing, let's say that we only knew the adjacent side and the hypotenuse. Well, we would be taking the inverse of our cosine and then finding that using our adjacent side and our hypotenuse. And then finally, if we knew our opposite and our adjacent side, we would just be taking the inverse tangent and finding theta. Okay, so these are our big six trig functions, if you will. The remainder of this tutorial, again, this is kind of just a review of the big concepts of trigonometry. The rest of this screencast is going to be going through example problems about how we actually use this stuff. So, our first sample problem. And again, with physics, I don't know exactly what your trigonometry class looked like, but I'm guessing it wasn't in maybe a more of a real-world context. I want to keep all of these problems that we do in a very real-world context, using examples that you could see in everyday life. So to begin, our first sample problem here. On a sunny day, a tall building casts a shadow that is 67.2 meters long. The angle between the sun's rays and the ground is 50 degrees. Determine the height of the building. So the first step that I would encourage you all to do is to draw a picture of the situation. So magically I have a picture that popped up here. It wasn't really magic, I did that because I'm awesome. All right, anyway, so what we're looking at here is we have our sun, Mr. Golden Sun, please shine down on me. All right, and we have the length of our shadow, 67.2 meters, and then we have that angle that the sun's rays or between the sun and the ground. Okay, the sun's rays and the ground. And we can simplify this picture if we wanted to. We could actually just draw a triangle here. Okay, so we could have our 67.2 meters. We could have our theta. All right. So we have to determine the height of the building. And what we need to figure out here is what information do we know? Well, we know theta, correct? We know theta and we know an adjacent side. So what is this side? This is our height over here, okay? We need to know our height. So we know an adjacent side. We know theta. We do not know this opposite side, okay? It's opposite of our angle theta. So the relevant equation that we need to use here is going to be tangent of theta is equal to opposite over adjacent. Okay, now again, what do we need to find here? We need to find our opposite side. So we simply have to rearrange this equation. Okay, simple math here. So we're going to just be multiplying both sides by our adjacent side. Okay, so we're going to end up getting here opposite side is equal to tangent theta times our adjacent side. Okay, and we can just plug in our known information, correct? So we'll write in tangent of 50 degrees times 67.2 meters. And we are going to get, if we do some plugging and chugging, plug it into your calculator here, we're going to get an opposite side, or height of the building is equal to 80 meters. Okay, so it's really important, I think, especially with all physics problems. We're going to get deeper into the problem solving aspect of this stuff, but it's really important to draw a picture. Okay, maybe start out with an actual situation, and then if you can, simplify it down. Okay, I think the simplification made it very obvious here. We knew our theta, we knew our adjacent side, we had to find that opposite side, and if we keep in mind our trig functions, we knew that we needed to use our tangent theta trig function. Okay, our next scenario here, again, trying to keep it a little real world. A lakefront drops off gradually at some angle. For safety reasons, it is necessary to know how deep the lake is at various distances from the shore. To provide some information about the depth, a lifeguard rows out from shore a distance of 14 meters and drops a weighted line. By measuring the length of the line, the lifeguard determines the depth to be 2.25 meters. Okay, so our first question is, what is the angle of the drop-off? So our first question here needs to tip you off right away that we're going to have to use one of those inverse trig functions, because we're trying to find the angle, or theta, if we call it that. Okay, so again, our first step is going to be to draw a picture. All right, so again, my awesome picture popped up here. So here is the picture of the real world scenario. Okay, so we have our lifeguard 14 meters out from shore, and he drops his line 2.25 meters. Now I've simplified that down just into a triangle. It's kind of not a great looking triangle, but you get the picture here. Okay, so what do we know here? Oh, but I forgot to put my unit here. So what do we know here? Well, we know that we don't know theta, so that's very important. And we know we have to find that because that's what the problem says. So if theta is here, that means we know an opposite side and we know an adjacent side. So again, that needs to tip you off. So katoa, we know the opposite and the adjacent side. So we're going to have to use our inverse tangent function, okay? And this is really simple, okay? We just write theta, there we go. Theta is equal to the inverse tangent of opposite over adjacent. And we have these two pieces of information, so all we have to do is plug those numbers in. So we have tangent, inverse tangent rather, of 2.25 meters divided by 14 meters. And we're going to get an answer, or our angle of the drop-off, to be, let's see here, it is going to be 9.13 degrees. Okay? So that is the first part to our problem. Now, I'm not going to do the second part. The second part is asking us what would the depth of the lake be 22 meters from shore. What you need to do for this part is you need to imagine that this boat is extended out this way further, okay? So you would actually be imagining that boat would be maybe out here somewhere, okay? That boat's going to be out here somewhere. So that distance is actually going to be 22 meters, okay? And you need to find what this distance is, okay? But you know, again, you know your adjacent side, you know your theta, you know what that angle of drop-off is, so you should very easily be able to find the depth 22 meters from shore. So that, I'm going to challenge you to find that on your own. I hope that this screencast was helpful for you and it kind of maybe sparked your mind in terms of trigonometry and gave you a nice little review. We're going to be practicing this in class tomorrow, so I hope this is helpful, students, and I look forward to working with you on this tomorrow. Take care.